Okay, so please don't go into fits as you look at this. This has allowed me to realize that next year I need to teach this before assigning that Khan Academy. My apologies, y'all are my guinea pigs. Okay, so I'm gonna show you a few of these. You have already figured this out and know how to do this from having to do the Khan Academy. Oh, but you live and learn, don't you? Okay, so this is the type where it's called solving with multiple degrees. Okay, so you solve this exactly how you do the others. Again, we have done this, you have done this, you have taught yourselves how to do this, or I've worked with some of you to figure out how to do this. Okay, so essentially we solve the same way we do normally. We try to get the cosine by itself, and then you do the inverse cosine of both sides. Inverse cosine of both sides. So you're left with 3t equals the inverse cosine of 1/2. So here's what you're trying to do. If you look back at this, you're trying to find where does cosine, disregarding the 3t at this point, where does cosine equal 1/2? So if you think about your unit circle, try to find that reference angle. So I'm using my hand trick. Where does cosine equal 1/2? Well, cosine is my x. So where does my x end up as that? 1. So that happens at 60 degrees. Okay, so that happens at 60 degrees here at 1/2. And then where else is cosine positive? Well, cosine is also positive down here in the 4th quadrant. So you do 360 minus 60 to get this, which is 300 degrees. So we know the inverse cosine actually has 2 solutions. So you have to set up 2 equations and say 3t equals 60 degrees, and then 3t also equals 300 degrees. So then you have to go ahead and solve both of those. What would you do if this is a normal equation? Now it's a single variable equation. Well, you just divide both sides by 3, right? So my t is actually equal to 20 degrees, and my t is equal to 100 degrees. Okay, now here's the other deal. Typically, because this has no restrictions, you need to write this as a formula. So I've explained this to a few of you guys, so this is gonna be redundant for some of you, but what you need to think about is, what is the period of this function? So you're gonna have to flash back to graphs. I apologize again for giving you some really negative flashbacks today, but think back to graphing. What is that 3t affect? Pause it and think about it if you need to. But that 3t, that affects your period. Remember, that's a horizontal shrink by 1/3, so that makes your graph go up and down much more quickly. Well, how much more quickly? It changes your period from 360 degrees, or from 2 pi, to 360 divided by 3. It happens 3 times as fast, right? So you've shrunk it by 1/3, so it makes it go 1/3, 1/3, 1/3. So it does 3 periods in the same time it used to do 1. So as we write these as formulas, we're not saying that our period is 360 degrees. What's our period? Well, it's 120 degrees times n. This one is 100 degrees plus 120 n. So that is how you would write both of these as formulas. So if you've not yet turned in the Khan Academy, I know there are just a couple of you left, that might help you.